Picture this, a universe so vast, so ancient, that its edges stretch beyond the reach of human imagination. Billions of galaxies, each one a swirling sea of stars, drift through the endless expanse of space. And yet, in this infinite cosmos, there are objects so extraordinary, so luminous, that they outshine entire galaxies. These are quasars, mysterious, powerful, and ancient. Born in the earliest days of the universe, quasars are more than just cosmic wonders. They are the storytellers of the cosmos, holding secrets about how the universe grew from a chaotic, fiery beginning into the structured beauty we see today. Tonight, as you drift into relaxation, let's journey together to the dawn of time, where quasars first ignited, lighting up the darkness and shaping the universe as we know it. Where are you joining us from, and what time is it there? As you settle in, let the story of these cosmic giants carry you into a peaceful, star-filled dream. Now, let's take a closer look at what quasars truly are. Imagine a light so intense, so brilliant, that it can be seen from billions of light years away. That's the essence of a quasar. These extraordinary objects are among the brightest and most distant phenomena in the universe, powered by supermassive black holes at their cores. But what makes them so special? Picture a supermassive black hole, millions or even billions of times more massive than our sun, surrounded by a swirling disk of gas and dust. As this material spirals inward, it heats up to unimaginable temperatures, releasing vast amounts of energy in the form of light and radiation. This is what gives quasars their incredible brightness, outshining entire galaxies and making them visible across the cosmos. Quasars are not just dazzling lights in the sky, they are cosmic lighthouses, guiding astronomers through the vast expanse of the early universe. Because they are so distant, the light we see from quasars today began its journey billions of years ago, offering us a glimpse into the universe's infancy. They act as beacons, illuminating the conditions of a time when galaxies were just beginning to form, and the cosmos was a much younger, more chaotic place. By studying quasars, scientists can piece together the story of how the universe evolved, from its fiery beginnings to the structured beauty we observe today. So, as you relax and let your mind wander, think of quasars as not just distant lights, but as storytellers, revealing the secrets of a universe that existed long before our own. Now, let's journey back in time to the very beginnings of quasars. Picture the early universe, a place of unimaginable heat and density, where the first seeds of structure were just starting to take shape. In this chaotic environment, gravity began to pull matter together, forming the first clumps of gas and dust. Over time, these clumps grew larger and more massive, collapsing under their own weight to create the first supermassive black holes. These black holes, millions or even billions of times heavier than our sun, became the engines that would power quasars. But how did these black holes grow so massive, so quickly? The answer lies in the unique conditions of the early universe. Back then, the cosmos was filled with vast amounts of gas, swirling and colliding in a turbulent dance. As this gas fell into the growing black holes, it formed spinning disks around them, heating up to incredible temperatures, The friction and pressure within these disks generated enormous amounts of energy, lighting up the surrounding space and giving birth to the first quasars. These early quasars were not just bright, they were transformative. Their intense radiation and powerful winds pushed against the surrounding gas, shaping the environment around them. In some regions, this energy triggered the formation of stars and galaxies, while in others, it cleared away material, leaving behind vast voids. The birth of quasars marked a turning point in the universe's history, a moment when the cosmos began to transition from a formless sea of gas to the structured, galaxy-filled expanse we see today. As you drift into relaxation, imagine these ancient quasars, their light piercing through the darkness of the early universe, setting the stage for everything that would come after. They were not just cosmic phenomena, they were the architects of the universe's evolution, shaping the cosmos in ways we are only beginning to understand. And now, as we continue our journey, let's explore how these quasars became cosmic time machines, allowing us to peer back into the universe's earliest moments. Now, let's take a closer look at how quasars act as cosmic time machines, offering us a glimpse into the universe's distant past. Because light takes time to travel across the vast expanse of space, when we observe a quasar, we're not seeing it as it is today, but as it was billions of years ago. This incredible phenomenon allows astronomers to study the early universe in ways that would otherwise be impossible. Imagine looking at a quasar located 10 billion light years away. The light reaching us now left that quasar 10 billion years ago, when the universe was still in its infancy. By analyzing this ancient light, scientists can uncover details about the conditions of the early cosmos, such as the composition of gas, the density of matter, and even the temperature of the universe at that time. It's like opening a window into the past, revealing the universe's formative years. Quasars are particularly valuable because they are so bright and distant. Their intense light cuts through the darkness of space, allowing us to study regions that would otherwise remain hidden. By examining the spectra of quasar light, astronomers can identify the chemical elements present in the early universe and trace how these elements evolved over time. This information helps us piece together the story of how the first stars and galaxies formed, and how the universe transitioned from a simple, uniform state to the complex, structured cosmos we see today. What's even more fascinating is that quasars can act as cosmic magnifying glasses. When their light passes through massive objects like galaxies or galaxy clusters, it bends and distorts, creating a phenomenon known as gravitational lensing. This effect not only magnifies the quasar's light, but also allows astronomers to study the properties of the intervening objects, providing even more clues about the universe's history. As you relax and let your mind wander, picture these ancient quasars, their light traveling across billions of years to reach us. They are not just distant objects, they are messengers from the past, carrying stories of the universe's earliest moments. And as we continue our journey, we'll explore how these quasars illuminated the cosmos, bringing an end to the cosmic dark ages and setting the stage for the universe we know today. Now, let's step back even further in time, to a moment when the universe was nothing like the vast, structured cosmos we know today. Picture the early universe, a place of unimaginable energy and chaos. In its infancy, the universe was incredibly dense and hot, a seething cauldron of particles and radiation. There were no stars, no galaxies, no planets, just a swirling, turbulent sea of matter and energy, compressed into a space far smaller than it occupies today. This was a time when the universe was so hot that atoms couldn't even form. Electrons and protons roamed freely, colliding and scattering in a frenzied dance. The entire cosmos was filled with a glowing, opaque fog of plasma, so thick that light couldn't travel far before being absorbed and re-emitted. It was a world of constant motion, where the forces of nature battled for dominance, shaping the raw materials of the universe into something entirely new. Amidst this chaos, the seeds of quasars were sown. As the universe expanded and cooled, tiny fluctuations in density began to grow. These fluctuations, born from the earliest moments of the Big Bang, acted like cosmic fingerprints, marking the places where matter would eventually clump together. In the densest regions, gravity began to take hold, pulling gas and dust into massive clouds. Over time, these clouds collapsed under their own weight, forming the first supermassive black holes, the engines that would one day power quasars. But this process wasn't quick or orderly. The early universe was a place of extremes, where violent collisions and explosive events were commonplace. As matter continued to gather around these growing black holes, the intense gravitational forces generated immense heat and pressure. Gas swirled into accretion disks, spinning faster and faster as it was pulled inward. Friction and magnetic fields heated the gas to millions of degrees, causing it to glow with a brilliance that could outshine entire galaxies. And so, in the midst of this cosmic storm, the first quasars ignited. Their light pierced through the surrounding chaos, cutting through the dense fog of the early universe. These quasars were not just beacons of light. They were the first signs of structure in a universe that had been formless and chaotic. They marked the beginning of a new era, one where the universe would slowly transform from a turbulent sea of energy into the organized, star-filled cosmos we see today. As you drift into this ancient scene, imagine the raw power and energy of the early universe. Feel the heat, the motion, the sheer intensity of a cosmos in its infancy. And as we continue, we'll explore how these first quasars brought light to the darkness, ending the cosmic dark ages and setting the stage for the universe's next great chapter. Now, let's turn our attention to a pivotal moment in cosmic history, the moment when the first quasars ignited, bringing light to a universe shrouded in darkness. Imagine a time when the cosmos was still cloaked in a thick, impenetrable fog of gas and plasma. Light struggled to travel freely, trapped in a cycle of absorption and re-emission. This was the cosmic dark ages, a period when the universe was devoid of stars, galaxies, or any source of illumination. But deep within this darkness, something extraordinary was happening. In the densest regions of the early universe, supermassive black holes had begun to form, drawing in vast amounts of gas and dust. As these black holes grew, their immense gravitational pull created swirling disks of superheated material around them. Friction and magnetic forces within these disks generated temperatures reaching millions of degrees, causing the gas to glow with an intensity unlike anything the universe had ever seen. And then it happened. The first quasars burst into existence, their light piercing through the cosmic fog like beacons in the night. These quasars were not just bright, they were dazzling, outshining everything around them. Their light traveled across the universe, breaking free from the opaque haze that had dominated for so long. For the first time, the cosmos was illuminated, and the cosmic dark ages began to fade. This moment marked a turning point in the history of the universe. The light from quasars didn't just end the darkness, it also played a crucial role in transforming the cosmos. As their radiation spread, it began to ionize the surrounding gas, stripping electrons from atoms and creating a more transparent universe. This process, known as reionization, allowed light to travel freely, paving the way for the formation of stars and galaxies. Picture the awe-inspiring sight of those first quasars, their light cutting through the darkness like cosmic lighthouses. They were the universe's first true sources of illumination, signaling the dawn of a new era. And as we continue, we'll explore how these quasars not only lit up the cosmos, but also shaped its future, setting the stage for the rich tapestry of galaxies and stars we see today. Now, let's journey further into the story of quasars and uncover their profound influence on the formation of galaxies. As those first quasars blazed into existence, they didn't just light up the cosmos, they also played a vital role in shaping its structure. Think of quasars as cosmic seeds, planted in the fertile soil of the early universe, from which galaxies would eventually grow. Quasars, with their immense energy and radiation, acted as catalysts for change. Their powerful light and winds pushed against the surrounding gas, compressing it and triggering the collapse of dense regions. These collapsing clouds of gas became the birthplaces of the first stars and eventually entire galaxies. It's as if quasars were cosmic gardeners, tilling the universe and preparing it for the growth of something far greater. But their influence didn't stop there. The supermassive black holes at the hearts of quasars also played a key role. As these black holes consumed matter, they released enormous amounts of energy, heating the surrounding gas and preventing it from cooling too quickly. This delicate balance allowed galaxies to form gradually, rather than all at once, ensuring they grew into the diverse and complex structures we see today. Quasars also help distribute heavy elements across the universe. When stars formed in the vicinity of quasars, they lived fast and died young, exploding as supernovae and scattering elements like carbon, oxygen, and iron into space. These elements became the building blocks for new stars, planets, and even life itself. In this way, quasars not only shaped galaxies, but also enriched the cosmos with the ingredients necessary for complexity and diversity. Picture the early universe as a vast, interconnected web, with quasars at its nodes. Their energy and influence rippled outward, creating pockets of structure and order in what was once a chaotic sea of gas. Over billions of years, these pockets grew into the galaxies we now observe, each one a testament to the enduring legacy of quasars. As we continue, we'll explore how these cosmic beacons not only shaped galaxies, but also connected them, weaving the universe into the intricate tapestry we know today. The story of quasars is not just one of light and energy. It's a story of creation, connection, and the birth of the cosmos as we know it. Now, let's turn our attention to the engines behind quasars' supermassive black holes. These colossal objects, millions or even billions of times more massive than our sun, are the driving force behind the incredible energy and light that quasars emit. But how exactly do they work, and what makes them so powerful? At the heart of every quasar lies a supermassive black hole, surrounded by a swirling disk of gas and dust, known as an accretion disk. As material from this disk spirals inward, it heats up to extreme temperatures, glowing brightly and releasing vast amounts of energy. This process is what makes quasars some of the brightest objects in the universe. But the true power of supermassive black holes lies in their ability to convert matter into energy with astonishing efficiency. As matter falls into the black hole, it doesn't just disappear. It gets stretched, compressed, and accelerated to near light speeds, releasing energy in the form of light, heat, and even powerful jets of particles. These jets can extend for thousands of light years, shooting out from the poles of the black hole at incredible speeds. What's truly remarkable is the scale of this energy release. A single quasar can outshine an entire galaxy, emitting more energy in a second than our sun will produce in its entire lifetime. This energy doesn't just light up the cosmos, it also shapes it, influencing the formation of stars, galaxies, and even the large-scale structure of the universe. Supermassive black holes are also incredibly efficient at recycling energy. As they consume matter, they release radiation that can push gas and dust outward, creating bubbles of hot, ionized gas that expand into the surrounding space. This process helps regulate the growth of galaxies, preventing them from growing too quickly or collapsing under their own gravity. In a way, supermassive black holes are like cosmic power plants, converting raw material into energy on a scale that's almost impossible to comprehend. They are the ultimate engines of creation, driving the evolution of the universe and leaving their mark on everything they touch. As we move forward, we'll explore how these powerful objects not only fuel quasars, but also serve as cosmic beacons, helping us map the universe and understand its deepest mysteries. The story of supermassive black holes is one of power, precision, and the incredible forces that shape our cosmos. Now, let's shift our gaze to the role quasars play as cosmic beacons, guiding astronomers through the vast expanse of the universe. These luminous objects are not just fascinating in their own right, they also act as signposts, helping us chart the large-scale structure of the cosmos. Imagine quasars as distant lighthouses, their light piercing through the darkness of space. Because they are so incredibly bright, they can be seen from billions of light years away, making them ideal markers for mapping the universe. Astronomers use quasars to trace the distribution of matter across vast distances, revealing the intricate web of galaxies, gas, and dark matter that forms the backbone of the cosmos. One of the most remarkable ways quasars help us map the universe is through their light. As this light travels through space, it passes through clouds of gas and dust, leaving behind a kind of fingerprint. By analyzing these fingerprints, Scientists can determine the composition, temperature, and density of the material the light has traveled through. This process, known as spectroscopy, allows astronomers to create detailed maps of the universe's structure, even in regions that are otherwise invisible to us. Quasars also play a key role in understanding the cosmic web, the vast network of filaments and voids that make up the universe. By studying the positions and distances of quasars, astronomers can piece together how matter is distributed on the largest scales. This helps us understand how galaxies form and evolve, and how the universe has expanded over billions of years. But quasars don't just help us map the universe, they also provide clues about its history. Because they are so distant, their light has been traveling for billions of years before reaching us. This means that when we observe a quasar, we're essentially looking back in time, seeing the universe as it was when the quasar's light first began its journey. By studying quasars at different distances, astronomers can create a timeline of the universe's evolution, from its earliest moments to the present day. In a way, quasars are like cosmic time capsules, preserving information about the universe's past and helping us understand its future. They are not only beacons of light, but also beacons of knowledge, illuminating the mysteries of the cosmos and guiding us toward a deeper understanding of our place in the universe. As we continue our journey, we'll explore how quasars have shaped the universe on an even grander scale, influencing the formation of galaxies and the very fabric of space itself. The story of quasars is one of discovery, connection, and the endless quest to understand the cosmos. Now, let's turn our attention to one of the most transformative roles quasars played in the early universe: their contribution to reionization. This pivotal process marked a dramatic shift in the cosmos, turning it from a neutral, opaque state into the ionized, transparent universe we see today. After the Big Bang, the universe was a hot, dense soup of particles. As it expanded and cooled, electrons and protons combined to form neutral hydrogen, creating a kind of cosmic fog. For hundreds of millions of years, this fog shrouded the universe, blocking light from traveling freely. This period is often called the cosmic dark ages. But then, something extraordinary happened. The first quasars ignited, and their intense radiation began to ionize the surrounding hydrogen. This means the energy from quasars stripped electrons away from hydrogen atoms, breaking them apart and turning the neutral gas into a sea of charged particles. Over time, this process spread across the universe, clearing the fog and allowing light to travel unimpeded. Quasars were not the only contributors to reionization. Early stars and galaxies also played a role, but their immense power made them key players. The energy emitted by quasars was so intense that it could ionize hydrogen over vast distances, far beyond the reach of smaller sources. This made quasars cosmic pioneers, carving out the first transparent regions in the universe and paving the way for the light of stars and galaxies to shine through. The reionization process didn't happen all at once. It unfolded over hundreds of millions of years, with quasars and other sources gradually ionizing the universe in patches. By studying quasars from this era, astronomers can piece together how and when reionization occurred, giving us a clearer picture of the universe's evolution. This transformation was a turning point in cosmic history. Without reionization, the universe would have remained shrouded in darkness, and the light from stars and galaxies would never have reached us. Quasars, with their incredible energy and reach, helped lift the veil, revealing the universe in all its brilliance. As we move forward, we'll explore how quasars didn't just illuminate the universe, they also shaped its very structure, influencing the formation of galaxies and the cosmic web. The story of quasars is one of light, transformation, and the enduring quest to understand the cosmos. Now, let's take a closer look at how quasars are woven into the very fabric of the universe, the cosmic web. Picture this. The universe isn't just a random scattering of galaxies and stars. Instead, it's structured like an intricate spiderweb, with threads of dark matter and gas connecting galaxies across unimaginable distances. This vast network is what astronomers call the cosmic web, and quasars play a fascinating role within it. Quasars are often found at the intersections of these cosmic threads, where the density of matter is highest. These intersections, known as nodes, are like bustling hubs in a cosmic city. Here, supermassive black holes at the hearts of quasars feast on the surrounding gas and dust, releasing tremendous amounts of energy. This energy doesn't just light up the quasar, it also influences the surrounding cosmic web, shaping the way galaxies form and evolve. The cosmic web itself is made up of dark matter, which acts as an invisible scaffold, and ordinary matter, which clumps together to form galaxies, stars, and planets. Quasars, with their immense gravitational pull and energetic radiation, help regulate the flow of matter along these threads. They can either encourage the growth of galaxies by funneling gas toward them, or suppress star formation by heating up the surrounding gas, making it too turbulent to collapse into stars. What's truly remarkable is how quasars serve as markers for the cosmic web. Because they are so bright and visible across vast distances, astronomers use them to map the large-scale structure of the universe. By studying the distribution of quasars, scientists can trace the outlines of the cosmic web, revealing the hidden architecture of the cosmos. This connection between quasars and the cosmic web highlights just how interconnected the universe is. Quasars aren't just isolated beacons of light, they're integral to the cosmic ecosystem, influencing the growth and distribution of galaxies across billions of light years. As we continue our journey, we'll explore another fascinating aspect of quasars, their powerful jets, which stretch across the universe at nearly the speed of light. These jets are not only awe-inspiring, but also play a crucial role in shaping the cosmos around them. Now, let's turn our attention to one of the most mesmerizing features of quasars, their jets. These are not just ordinary streams of particles. They are colossal beams of energy that stretch across the universe at speeds so close to the speed of light that they challenge our understanding of physics itself. Imagine a cosmic fire hose blasting out matter and radiation with such force that it can travel millions of light years into space. Quasar jets are born from the intense environment surrounding supermassive black holes. As matter spirals into the black hole, not all of it is consumed. Some of it gets funneled into powerful magnetic fields, which act like cosmic particle accelerators. These fields channel the material into narrow, high-speed jets that shoot out from the poles of the black hole. The result is a breathtaking display of energy, with jets that can extend far beyond the boundaries of their host galaxies. What makes these jets so fascinating is their sheer power. They carry enough energy to influence the surrounding universe, heating up gas and dust, and even triggering or halting star formation in distant galaxies. The particles within these jets move so fast that they emit light across the electromagnetic spectrum, from radio waves to gamma rays. This makes quasar jets some of the brightest objects in the universe, visible across vast cosmic distances. But there's a twist. When we observe these jets, they sometimes appear to move faster than the speed of light. This is an optical illusion caused by the jets traveling almost directly toward us at near light speeds. It's a phenomenon known as superluminal motion, and it's a reminder of just how extreme the physics of quasars can be. These jets also play a crucial role in shaping the cosmos. As they travel through space, they interact with the surrounding gas and dust, carving out vast cavities and influencing the growth of galaxies. In some cases, they can even trigger the formation of new stars by compressing gas clouds. In others, they can suppress star formation by heating up the gas and making it too turbulent to collapse. As we continue to study quasar jets, they reveal more about the universe's most extreme environments. They are not just spectacular to observe, they are also key to understanding how energy and matter are distributed across the cosmos. Next, we'll explore how quasars influence the birth of stars, shedding light on their dual role as both creators and destroyers in the cosmic dance of galaxy formation. Now, let's shift our gaze to the cosmic interplay between quasars and the birth of stars. Quasars, with their immense energy and powerful jets, have a dual role in the universe. They can both ignite and extinguish the fires of star formation. This delicate balance makes them key players in shaping the early cosmos. In some regions, quasars act as cosmic catalysts, triggering the birth of stars. Their jets, as we've seen, carry enormous amounts of energy. When these jets collide with dense clouds of gas and dust, they compress the material, creating the perfect conditions for stars to form. Imagine a cosmic sculptor shaping raw materials into glowing spheres of light. This process is particularly important in the early universe, where vast reservoirs of gas were waiting to be transformed into the first generations of stars. But quasars can also play the role of cosmic extinguishers. In other regions, their intense radiation and powerful winds heat up the surrounding gas, making it too hot and turbulent to collapse into stars. It's like trying to build a sandcastle in a hurricane. The conditions simply aren't right. This suppression of star formation can have a profound impact on the evolution of galaxies, leaving some regions barren while others flourish with stellar activity. What's truly fascinating is how these two opposing forces coexist. In the same galaxy, a quasar might be nurturing stars in one region while stifling them in another. This duality highlights the complexity of the early universe, where the actions of a single quasar could shape the destiny of entire galaxies. As we study these processes, we gain a deeper understanding of how the universe evolved from a chaotic, gas-filled expanse into the structured cosmos we see today. Quasars, with their dual nature, remind us that creation and destruction are often two sides of the same cosmic coin. Next, we'll journey through the life cycle of a quasar, tracing its path from birth to fading, and uncovering the secrets of its fleeting yet impactful existence. Now, let's take a closer look at the life cycle of a quasar, a journey that spans billions of years and reveals the incredible forces at work in the universe. Like all cosmic phenomena, quasars have a beginning, a middle, and an end, each phase marked by dramatic changes in their behavior and impact on the cosmos. The story of a quasar begins with the birth of a supermassive black hole. In the early universe, vast clouds of gas and dark matter collapsed under their own gravity, forming the seeds of these colossal objects. As the black hole grew, it began to pull in surrounding material, creating a swirling disk of gas and dust around it. This disk, heated to extreme temperatures, began to glow brightly, marking the birth of a quasar. At this stage, the quasar is a beacon of light, shining with the energy of billions of stars. As the quasar matures, it enters its most active phase. The supermassive black hole at its core continues to devour gas and dust, releasing immense amounts of energy in the form of light, heat, and powerful jets. These jets, traveling at nearly the speed of light, can stretch across millions of light years, carving out vast regions of space and influencing the formation of galaxies. During this time, the quasar is at its brightest, illuminating the cosmos and shaping the structures around it. But even quasars cannot burn forever. Over time, the supply of gas and dust feeding the black hole begins to dwindle. As the fuel runs low, the quasar's brightness starts to fade. The once vibrant disk around the black hole grows dimmer and the jets weaken. This marks the beginning of the quasar's decline, a slow but inevitable process that unfolds over millions of years. Eventually, the quasar enters its final phase, fading into obscurity. With no more material to consume, the black hole becomes quiet, and the quasar's light fades away. What remains is a dormant supermassive black hole, surrounded by the remnants of its once glorious activity. Though the quasar itself is gone, its legacy lives on in the galaxies it helped shape and the cosmic structures it influenced. The life cycle of a quasar is a testament to the dynamic and ever-changing nature of the universe. From its explosive birth to its quiet end, a quasar's journey is a reminder of the delicate balance between creation and destruction, and the profound impact these cosmic giants have on the cosmos. Next, we'll explore the mysterious relationship between quasars and dark matter, uncovering how these invisible forces shape the universe in ways we are only beginning to understand. Now, let's turn our attention to the invisible threads that weave through the cosmos, dark matter, and its fascinating connection to quasars. While quasars shine brightly, their existence is deeply intertwined with something we cannot see: dark matter. This mysterious substance, which makes up about 85% of the universe's mass, plays a crucial role in shaping the structures we observe, including quasars. To understand how quasars and dark matter are linked, we need to look back to the early universe. In those formative moments, dark matter began to clump together, forming vast halos that acted as gravitational anchors. These halos pulled in ordinary matter, gas, and dust, creating the dense environments needed for supermassive black holes to form. Without the gravitational pull of dark matter, the gas and dust might have remained scattered, never coalescing into the massive objects that would later become quasars. As these dark matter halos grew, they provided the scaffolding for galaxies and quasars to emerge. The gas and dust drawn into these halos began to collapse, heating up and forming the swirling disks around supermassive black holes. This process not only gave birth to quasars, but also allowed them to thrive, as the dark matter halos continued to funnel material toward the black holes, fueling their incredible energy output. But the relationship between quasars and dark matter doesn't end there. Dark matter also influences how quasars are distributed across the universe. Because dark matter forms a vast cosmic web, quasars tend to appear along the filaments and nodes of this web, marking the densest regions of the universe. This alignment helps astronomers map the large-scale structure of the cosmos, using quasars as beacons to trace the invisible hand of dark matter. Even more intriguing is the possibility that dark matter itself might play a role in the behavior of quasars. Some theories suggest that dark matter particles could interact with the supermassive black holes at the hearts of quasars, influencing their growth or even the formation of their powerful jets. While this remains an area of active research, it highlights the profound connection between these two cosmic phenomena. In essence, dark matter is the unseen architect behind the scenes, shaping the environments where quasars are born and thrive. Without it, the universe as we know it, filled with luminous quasars and intricate cosmic structures, might look very different. As we continue to explore this relationship, we uncover not only the secrets of quasars, but also the hidden forces that govern the cosmos. Next, we'll delve into the mesmerizing phenomenon of quasar jets, exploring how these powerful streams of particles travel at nearly the speed of light, and what they reveal about the universe's most energetic processes. Now, let's take a moment to listen to the universe in a way you might not have imagined before. While quasars are known for their dazzling light and immense energy, they also produce something else, something we can't see but can hear. Scientists have found a way to translate the emissions from quasars into sound, turning the invisible into something tangible and, surprisingly, soothing. Imagine the hum of a quasar, a deep, resonant tone that echoes across billions of light years. This sound isn't something you'd hear with your ears in space, of course, but through a process called sonification. Astronomers have transformed the data from quasar emissions into audible frequencies. The result is a cosmic symphony, a blend of low, rumbling notes and gentle, shimmering tones that evoke the vastness and mystery of the universe. The process begins with the light emitted by quasars, which is captured by telescopes and broken down into its component wavelengths. These wavelengths are then mapped to different musical notes, creating a soundscape that reflects the quasar's unique energy signature. The deeper tones represent the lower energy emissions, while the higher pitches correspond to the more energetic parts of the spectrum. Together, they form a harmonious yet otherworldly melody. What makes these sounds so captivating is their ability to transport us. As you listen, you might feel as though you're drifting through the cosmos, carried by the gentle waves of quasar emissions. The sounds are not just random noise. They tell a story, one of immense power and beauty, of a universe that sings in ways we're only beginning to understand. For those seeking a moment of calm, the sounds of quasars offer a unique form of relaxation. Their steady, rhythmic tones can help quiet the mind, inviting you to lose yourself in the vastness of space. It's a reminder that even in the chaos of the universe, there is a kind of order, a rhythm that connects everything. As we continue our journey through the cosmos, let's carry this auditory experience with us, letting the sounds of quasars guide our thoughts and dreams. Next, we'll explore how these cosmic beacons have shaped the evolution of the universe, from their fiery beginnings to their lasting influence on the stars and galaxies we see today. Now, let's turn our attention to the profound role quasars have played in the grand story of cosmic evolution. From the earliest moments of the universe to the present day, these luminous giants have been more than just distant wonders. They've been architects of the cosmos itself. In the early universe, quasars were among the first structures to form, emerging from the dense, chaotic soup of matter and energy that followed the Big Bang. Their immense energy output didn't just light up the darkness, it helped shape the very fabric of the universe. As quasars blazed into existence, their radiation ionized the surrounding gas, breaking apart neutral hydrogen atoms and paving the way for the universe to become transparent. This process, known as reionization, was a critical turning point, allowing light to travel freely and setting the stage for the formation of stars and galaxies. But quasars didn't stop there. Their supermassive black holes, the engines powering their brilliance, also played a key role in the growth of galaxies. As matter spiraled into these black holes, it released vast amounts of energy, heating the surrounding gas and regulating star formation. In some regions, this energy suppressed the birth of new stars, while in others, it triggered bursts of star formation, sculpting the galaxies we see today. Over billions of years, quasars have continued to influence the universe, acting as cosmic lighthouses that guide our understanding of its structure. Their light, traveling across unimaginable distances, carries clues about the distribution of matter and the large-scale web of galaxies that spans the cosmos. Even as many quasars have faded into obscurity, their legacy endures in the galaxies they helped shape and the light they once emitted. Today, quasars remain a window into the universe's past, offering insights into how it evolved from a hot, dense state to the vast, intricate tapestry we observe now. They remind us that the universe is not static, but a dynamic, ever-changing entity, shaped by forces both immense and subtle. As we reflect on the journey of quasars, we're reminded of their enduring impact, not just as distant beacons of light, but as key players in the story of cosmic evolution. Next, we'll delve into the discovery of the largest known quasar, a cosmic giant that continues to inspire awe and wonder. Now, let's journey to the far reaches of the cosmos to meet the largest known quasar ever discovered, a true titan of the universe. This colossal object, known as J035 plus 01241, is a staggering testament to the immense power and scale of these cosmic phenomena. Located more than 12 billion light-years away, this quasar shines with the brightness of over 600 trillion suns, making it one of the most luminous objects in the known universe. At its heart lies a supermassive black hole, weighing in at an astonishing 66 billion times the mass of our Sun. To put that into perspective, imagine a black hole so massive that it could swallow our entire solar system without a second thought. The energy radiating from this quasar is so intense that it outshines entire galaxies, casting a brilliant light that has traveled across the universe for billions of years to reach us. The discovery of this quasar was a monumental moment in astronomy, offering scientists a rare glimpse into the early universe. Its immense size and brightness provide valuable clues about the conditions that allowed such massive structures to form so soon after the Big Bang. Researchers believe that quasars like this one played a crucial role in shaping the cosmos, influencing the formation of galaxies and the distribution of matter on a grand scale. What makes this quasar even more awe-inspiring is the sheer scale of its jets, streams of particles that shoot out from its core at nearly the speed of light. These jets stretch across millions of light years, carving out vast regions of space and leaving behind a trail of ionized gas. They are a vivid reminder of the raw power contained within these cosmic giants, capable of shaping the universe on a scale that is almost beyond comprehension. As we marvel at the size and brilliance of this quasar, we are reminded of the incredible forces at work in the universe. It challenges our understanding of what is possible, pushing the boundaries of science and imagination. This quasar is not just a distant object in the night sky. It is a beacon of discovery, illuminating the mysteries of the cosmos and inspiring us to explore further. Next, we'll explore how quasars challenge our understanding of the speed of light, revealing fascinating insights into the nature of space and time. Now, let's turn our attention to one of the most mind-bending aspects of quasars, how they seem to defy our understanding of the speed of light. At first glance, the jets streaming from quasars appear to move faster than light itself, a phenomenon that has puzzled scientists and sparked countless debates. But here's the twist. This apparent faster-than-light motion is actually an optical illusion, a trick of perspective that reveals just how strange and fascinating the universe can be. These jets, composed of high-energy particles, shoot out from the quasar's core at speeds approaching the speed of light. When we observe them from Earth, the angle at which we view these jets creates an illusion known as superluminal motion. Essentially, because the jets are moving almost directly toward us, the light they emit at different points along their path reaches us almost simultaneously. This makes it seem as though the jets are moving faster than light, even though they're not. It's like watching a cosmic magic trick, where the universe plays with our perception of time and space. This phenomenon isn't just a curiosity, it's a powerful tool for astronomers. By studying these jets, scientists can learn more about the extreme environments around supermassive black holes and the physics that govern them. It also challenges us to rethink our assumptions about the universe. The speed of light, long considered the ultimate speed limit, remains unbroken, but quasars show us that the cosmos is full of surprises that stretch our understanding of reality. As we continue to explore the mysteries of quasars, we'll next delve into their speculative connection to the multiverse, a concept that takes us even further into the realms of imagination and discovery. Now, let's venture into a realm where science meets speculation, the intriguing connection between quasars and the multiverse. While quasars themselves are already cosmic enigmas, their potential link to the multiverse theory opens up a whole new dimension of questions about the nature of reality. Could these luminous beacons be more than just remnants of the early universe? Could they hold clues to the existence of other universes beyond our own? The multiverse theory suggests that our universe might be just one of countless others, each with its own unique set of physical laws and constants. Some scientists speculate that quasars, with their extreme energy and mysterious origins, might serve as windows into these alternate realities. Imagine quasars as cosmic portals, their intense light and radiation potentially carrying traces of other universes. While this idea is still highly speculative, it's a fascinating thought experiment that pushes the boundaries of our understanding. One intriguing possibility is that quasars could be the result of interactions between our universe and others. In some multiverse models, collisions or overlaps between universes could create regions of intense energy, giving rise to phenomena like quasars. These cosmic collisions might leave behind signatures in the form of unusual patterns in quasar light or radiation, offering tantalizing hints of a multiverse. While we don't yet have the tools to confirm such theories, the very idea invites us to dream bigger and question deeper. What makes this connection even more compelling is how it challenges our perception of reality. If quasars are indeed linked to the multiverse, they could redefine our understanding of existence itself. Are we living in just one of many universes, each with its own quasars lighting up the cosmic darkness? The thought is both humbling and exhilarating, reminding us that the universe, or multiverse, is far stranger and more complex than we can imagine. As we ponder these possibilities, we're reminded that quasars are more than just relics of the past. They are cosmic storytellers, offering glimpses into the deepest mysteries of existence. And as we continue to explore their secrets, we'll next turn our attention to how quasars have inspired myths and stories across cultures, blending science with imagination in ways that captivate the human spirit. Now, let's take a step back from the cosmos and explore how quasars have ignited the human imagination, weaving their way into myths and stories across cultures. While quasars are a relatively recent discovery in the grand timeline of human history, their awe-inspiring nature has already begun to influence how we think about the universe and our place within it. Across the globe, quasars have become symbols of mystery, power, and the infinite, blending science with the timeless art of storytelling. In many ways, quasars have taken on roles similar to those of ancient celestial phenomena like comets or supernova. Just as our ancestors looked to the stars for guidance and meaning, modern storytellers have turned to quasars as metaphors for the unknown and the extraordinary. In science fiction, quasars often appear as cosmic gateways or sources of unimaginable energy, fueling the adventures of explorers and the dreams of dreamers. Their brilliance and distance make them perfect symbols for the unattainable, the mysterious, and the infinite. But quasars have also found their way into more grounded narratives, serving as reminders of humanity's small yet curious place in the universe. In some cultures, Quasars are seen as celestial lighthouses, guiding lost souls or illuminating the path to enlightenment. Their light, traveling billions of years to reach us, is often interpreted as a message from the distant past, a whisper from the early universe that connects us to the origins of everything. This idea resonates deeply with our innate desire to understand where we come from and where we might be headed. Interestingly, quasars have also inspired artistic interpretations, from paintings and poetry to music and film. Their ethereal beauty and otherworldly nature make them a natural muse for creators seeking to capture the sublime. Some artists imagine quasars as cosmic hearts, pulsing with energy and life, while others see them as celestial eyes, watching over the universe with an ancient, knowing gaze. These creative expressions remind us that science and art are not so different. Both seek to explore, explain, and celebrate the wonders of existence. As we reflect on the cultural impact of quasars, it's clear that they are more than just astronomical objects. They are symbols of our endless curiosity, our drive to explore the unknown, and our ability to find meaning in the vastness of the cosmos. And as we continue to uncover their secrets, we'll next turn our attention to the future of quasar research, where new technologies and discoveries promise to deepen our understanding of these cosmic marvels. As we look ahead, the future of quasar research shines brightly, promising to unlock even more secrets of these cosmic powerhouses. Scientists and astronomers around the world are gearing up with groundbreaking tools and technologies that will allow us to peer deeper into the universe than ever before. One of the most exciting developments is the next generation of telescopes, like the James Webb Space Telescope and the Extremely Large Telescope, which are set to revolutionize our ability to observe quasars in unprecedented detail. These instruments will not only capture sharper images, but also analyze the light from quasars with incredible precision, revealing clues about their formation, evolution, and the environments they inhabit. But it's not just about seeing farther, it's about understanding better. Advanced computer simulations and artificial intelligence are playing a growing role in quasar research, helping scientists model the complex processes that drive these objects. By combining observations with simulations, researchers can test theories about how supermassive black holes grow, how quasars influence their surroundings, and even how they contribute to the large-scale structure of the universe. This synergy between observation and theory is opening new doors to discovery, allowing us to piece together the story of quasars in ways that were once unimaginable. Another exciting frontier is the study of gravitational waves, ripples in space-time caused by massive cosmic events. While quasars themselves don't produce gravitational waves, the supermassive black holes at their centers might. Future observatories, like the Laser Interferometer Space Antenna, or LISA, could detect these waves, offering a completely new way to study quasars and the black holes that power them. This could provide insights into how these black holes merge, grow, and shape the galaxies around them. As we continue to push the boundaries of technology and knowledge, the mysteries of quasars are slowly giving way to understanding. Each new discovery brings us closer to answering fundamental questions about the universe, how it began, how it evolved, and what role quasars played in shaping the cosmos as we know it. And with every step forward, we're reminded that the universe is full of wonders waiting to be uncovered. Next, we'll explore how quasars might even hold clues to one of humanity's greatest questions: the search for extraterrestrial life. Now, let's turn our gaze to one of the most intriguing possibilities. Could quasars hold clues to the existence of extraterrestrial life? While quasars themselves are not places where life could thrive, given their extreme environments and the intense radiation they emit, they might still play a role in our search for life beyond Earth. These cosmic beacons, shining from the farthest reaches of the universe, could help us identify regions where life might have a chance to emerge and flourish. One way quasars could aid in this search is by acting as cosmic signposts. Their immense brightness allows us to study the galaxies and regions of space they illuminate, even from billions of light years away. By analyzing the light that passes through the gas and dust surrounding quasars, astronomers can detect the presence of elements essential for life, such as carbon, oxygen, and nitrogen. These elements, forged in the hearts of stars and scattered across the cosmos, are the building blocks of life as we know it. Quasars, in this sense, act like cosmic laboratories, revealing the chemical makeup of distant galaxies and helping us pinpoint where life-sustaining conditions might exist. Another fascinating angle is the role quasars might play in shaping habitable environments. While the intense radiation from a quasar would make its immediate surroundings inhospitable, the energy and winds they produce can influence entire galaxies. These forces can trigger star formation, creating new solar systems with planets that might one day support life. In some cases, quasars might even clear away dense clouds of gas and dust, allowing light to penetrate regions that were once shrouded in darkness. This process could create pockets of space where life has the chance to take root and evolve. But perhaps the most tantalizing possibility is that quasars could serve as markers for advanced civilizations. Some theories suggest that highly advanced extraterrestrial societies might harness the energy of quasars, or even use them as beacons to communicate across vast distances. While this idea remains speculative, it sparks the imagination and reminds us that the universe is full of mysteries waiting to be explored. Quasars, with their incredible power and reach, might one day help us answer the profound question: are we alone in the cosmos? As we ponder these possibilities, it's worth remembering that the search for extraterrestrial life is not just about finding other beings. It's about understanding our place in the universe. Quasars, as both cosmic wonders and scientific tools, remind us of the vastness of space and the endless potential for discovery. And with every new insight they provide, we come one step closer to unraveling the mysteries of life itself. Next, we'll explore the mesmerizing beauty of quasar light and how it captivates both scientists and dreamers alike. Now, let's shift our focus to something equally captivating: the sheer beauty of quasar light. Imagine standing under a night sky, but instead of stars, you see the glow of quasars, their light traveling billions of years to reach your eyes. This light is not just a scientific marvel, it's a cosmic masterpiece, a symphony of colors and energy that paints the universe in ways we can barely comprehend. Quasar light is unlike anything else in the cosmos. It's born from the heart of supermassive black holes, where unimaginable forces twist and shape the fabric of space and time. As matter spirals into these black holes, it heats up to incredible temperatures, releasing bursts of light so intense that they outshine entire galaxies. This light, a blend of ultraviolet, visible, and even X-ray wavelengths, carries with it the story of the early universe, a story written in photons that have journeyed across eons. What makes quasar light so mesmerizing is its ability to cut through the darkness of space, illuminating the cosmic web and revealing the intricate structures that connect galaxies. When we observe this light, we're not just seeing a distant object, we're witnessing the echoes of a time when the universe was young and wild, a time when quasars reigned supreme. The light itself seems to shimmer with a kind of cosmic energy, as if it holds the secrets of creation within its beams. But there's also a tranquility to quasar light, a quiet beauty that belies its violent origins. When astronomers capture images of quasars, the light often appears as a soft, glowing halo, a gentle reminder of the vastness and mystery of the universe. It's a light that invites contemplation, urging us to pause and reflect on our place in the cosmos. In its glow, we find both wonder and peace, a reminder that even in the chaos of the universe, there is beauty to be found. As we marvel at the light of quasars, we're reminded of the incredible journey it has taken to reach us. Each photon is a messenger from the distant past, carrying with it the story of a universe in flux. And as we study this light, we're not just uncovering the secrets of quasars, we're connecting with the very essence of the cosmos itself. Next, we'll explore how quasars connect to the Big Bang, offering us a glimpse into the origins of everything we know. Now, let's take a step even further back in time, to the very beginning of everything, the Big Bang. Quasars, those brilliant beacons of light, are not just distant objects. They are cosmic time capsules, offering us a unique window into the universe's earliest moments. By studying quasars, we can trace the story of the cosmos back to its fiery birth, piecing together how the universe evolved from a hot, dense state to the vast, structured expanse we see today. The Big Bang marked the beginning of space, time, and all the matter and energy that would eventually form stars, galaxies, and of course, quasars. In the first moments after the Big Bang, the universe was a seething cauldron of particles and radiation, too hot and chaotic for anything stable to exist. But as the universe expanded and cooled, matter began to clump together, forming the first seeds of structure. It was within these early clumps that the first supermassive black holes, the engines powering quasars, began to take shape. Quasars give us a direct link to this era because they are so incredibly bright and distant. The light we see from quasars today began its journey when the universe was just a fraction of its current age. By analyzing this light, astronomers can study the conditions of the early universe, such as the density of matter, the temperature of space, and even the rate at which the universe was expanding. In a sense, quasars act as cosmic fossils, preserving the state of the universe as it was billions of years ago. One of the most fascinating insights quasars provide is about the process of reionization, a pivotal chapter in the universe's history. After the Big Bang, the universe was filled with a fog of neutral hydrogen gas, which blocked light from traveling freely. But as the first stars and quasars ignited, their intense radiation began to ionize this gas, clearing the fog and allowing light to travel across the cosmos. Quasars played a crucial role in this transformation, helping to shape the universe into the transparent, light-filled expanse we know today. By connecting quasars to the Big Bang, we gain a deeper understanding of how the universe evolved from its chaotic beginnings to the structured, luminous cosmos we inhabit. Quasars are not just distant objects, they are storytellers, revealing the history of the universe in their light. As we continue to study them, we uncover more about the origins of everything, from the smallest particles to the largest structures in the cosmos. Next, we'll explore how quasars might be linked to gravitational waves, offering yet another way to study the universe's most profound mysteries. Now, let's turn our attention to another fascinating connection in the cosmos: quasars and gravitational waves. These ripples in the fabric of space-time, first predicted by Albert Einstein over a century ago, have opened up an entirely new way to observe the universe. And quasars, with their immense energy and supermassive black holes, might hold the key to understanding how gravitational waves can reveal even more about the cosmos. Gravitational waves are created by some of the most violent and energetic events in the universe, such as the collision of black holes or neutron stars. When these massive objects merge, they send out ripples that travel through space-time, distorting the very fabric of the universe. But what does this have to do with quasars? Well, quasars are powered by supermassive black holes, and these black holes are often found at the centers of galaxies. When two galaxies collide, their central black holes can spiral toward each other, eventually merging in a cataclysmic event that produces gravitational waves. This means that quasars, or the remnants of quasars, could be directly linked to the sources of gravitational waves. By studying these waves, astronomers can learn more about the behavior of supermassive black holes and the environments in which they exist. For example, the frequency and strength of gravitational waves can tell us about the masses of the black holes involved and how they came together. This information, in turn, helps us understand how galaxies evolve and how quasars influence their surroundings. But the connection doesn't stop there. Some quasars are known to have jets, powerful streams of particles that shoot out from their black holes at nearly the speed of light. These jets can also produce gravitational waves, especially if they are unstable or if they interact with other objects in space. By detecting these waves, scientists could gain new insights into the physics of quasar jets and the extreme conditions near supermassive black holes. What makes this connection so exciting is that gravitational waves provide a completely different way to observe the universe. Unlike light, which can be blocked or distorted by dust and gas, gravitational waves travel unimpeded, carrying information from the most distant and hidden corners of the cosmos. By combining observations of quasars with gravitational wave data, astronomers can paint a more complete picture of the universe's history and structure. As we continue to explore this link, we're not just uncovering the secrets of quasars and black holes, we're also opening up new possibilities for understanding the universe itself. Gravitational waves offer a fresh perspective, allowing us to listen to the cosmos in a way we never could before. And with quasars as our guide, we're poised to discover even more about the forces that shape the universe. Next, we'll reflect on how quasars might influence the ultimate fate of the cosmos, tying their role to the grand story of cosmic destiny. As we venture further into the mysteries of the cosmos, let's consider how quasars might shape the ultimate fate of the universe. These luminous giants, powered by supermassive black holes, are not just relics of the past. They may hold clues to the future of everything we know. The story of quasars is deeply intertwined with the grand narrative of cosmic evolution, and their influence could extend far beyond their fiery brilliance. Quasars, with their immense energy output, play a significant role in shaping the large-scale structure of the universe. Their radiation and powerful jets can heat surrounding gas, preventing it from collapsing into new stars and galaxies. Over billions of years, this process could slow down the formation of new cosmic structures, gradually altering the universe's landscape. In this way, quasars act as cosmic regulators, balancing the birth and growth of galaxies across vast stretches of space and time. But their impact doesn't stop there. The supermassive black holes at the hearts of quasars are thought to grow by consuming matter and merging with other black holes. These mergers release gravitational waves, ripples in space-time that carry energy away from the system. Over trillions of years, as black holes continue to merge and grow, the universe could become quieter and darker, with fewer energetic events to light up the cosmos. This slow fading of activity might mark the beginning of a more subdued era in the universe's history. Some theories even suggest that quasars and their black holes could play a role in the universe's ultimate fate. If the expansion of the universe continues to accelerate, as current observations suggest, galaxies will drift farther apart, and the universe will grow colder and more diffused. In such a scenario, quasars and their black holes might be among the last sources of energy, shining faintly in an otherwise dark and empty cosmos. Eventually, even these beacons could fade, leaving the universe in a state of near total stillness. Yet, even in this distant future, the legacy of quasars would endure. The structures they helped shape galaxies, clusters, and the cosmic web would remain as silent monuments to the universe's vibrant past. And the gravitational waves they produced would continue to ripple through space-time, carrying echoes of their existence across the ages. Quasars remind us that the universe is a dynamic, ever-changing place, where even the most powerful forces are subject to the passage of time. As we ponder their role in cosmic destiny, we're reminded of the profound interconnectedness of all things, from the smallest particles to the largest structures in the cosmos. Next, we'll take an imaginative journey through a quasar, exploring its inner workings and marveling at the beauty of these cosmic powerhouses. Now, let's embark on an extraordinary journey, one that takes us deep into the heart of a quasar. Picture yourself approaching this cosmic powerhouse, a beacon of light so intense it outshines entire galaxies. As you draw closer, the sheer scale of its brilliance becomes overwhelming, a swirling maelstrom of energy that defies imagination. This is not just a distant object in the night sky. It's a gateway to understanding the raw forces that shape the universe. At the center of the quasar lies its engine, a supermassive black hole, millions to billions of times more massive than our sun. Surrounding it is an accretion disk, a glowing ring of gas and dust, spiraling inward at incredible speeds. The friction within this disk heats the material to unimaginable temperatures, causing it to emit light across the entire spectrum, from radio waves to X-rays. This is the source of the quasar's dazzling glow, a light so powerful it can be seen across billions of light years. As you venture closer, you notice the quasar's jets, twin beams of particles shooting out from the poles of the black hole at nearly the speed of light. These jets are cosmic particle accelerators, stretching for thousands of light years into the surrounding space. They carry energy and matter far beyond the quasar itself, influencing the growth of galaxies and the distribution of matter in the universe. The jets are a testament to the quasar's power, a reminder of its ability to shape the cosmos on a grand scale. The environment around the quasar is chaotic, yet mesmerizing. Magnetic fields twist and coil, channeling energy into the jets and creating intricate patterns of light and shadow. Gas clouds swirl and collide, their atoms ionized by the intense radiation. It's a place of constant motion, where the forces of gravity, magnetism, and radiation dance in a delicate balance. Despite the chaos, there's a strange beauty to it all, a symphony of energy and light that speaks to the universe's capacity for both destruction and creation. As you move through the quasar, you can't help but marvel at its sheer scale and complexity. It's a place where the laws of physics are pushed to their limits, where time and space are warped by the immense gravity of the black hole. Yet, amidst the chaos, there's a sense of order, a reminder that even the most powerful forces in the universe are governed by fundamental principles. This journey through a quasar is more than just a glimpse into the heart of a cosmic phenomenon. It's a reminder of the universe's boundless creativity and power. As we continue to explore the mysteries of quasars, we uncover not only the secrets of the early universe, but also the profound interconnectedness of all things. Next, we'll reflect on humanity's enduring fascination with these celestial wonders and the questions they inspire about our place in the cosmos. As we step back from the heart of the quasar, let's take a moment to reflect on what these cosmic wonders mean to us as humans. Quasars are more than just distant objects in the night sky. They are symbols of our insatiable curiosity and our relentless drive to understand the universe. From the moment we first glimpsed their light, quasars have captivated our imaginations, challenging us to ask deeper questions about the cosmos and our place within it. What is it about quasars that sparks such fascination? Perhaps it's their sheer power, their ability to outshine entire galaxies while sitting billions of light years away. Or maybe it's their mystery, the way they push the boundaries of what we know about physics, gravity, and the nature of existence itself. Quasars remind us that the universe is far stranger and more magnificent than we could ever imagine, and they inspire us to keep exploring, to keep seeking answers to the questions that have puzzled humanity for centuries. Throughout history, humans have looked to the stars for meaning, guidance, and inspiration. Quasars, with their brilliant light and enigmatic nature, have become modern-day celestial beacons, guiding astronomers and dreamers alike toward new discoveries. They remind us that the universe is not static. It's a dynamic, ever-changing tapestry of energy and matter, shaped by forces we are only beginning to understand. But quasars do more than just inspire scientific inquiry. They also remind us of the power of wonder. In a world that often feels small and familiar, quasars invite us to look beyond our everyday lives and consider the vastness of the cosmos. They challenge us to dream bigger, to think beyond the limits of our own experience, and to embrace the unknown with a sense of awe and humility. As we continue to study quasars, we uncover not only the secrets of the early universe, but also the enduring spirit of human curiosity. They remind us that exploration is not just about finding answers, it's about asking better questions, about pushing the boundaries of what we know and daring to imagine what lies beyond. In the light of quasars, we see not only the history of the cosmos, but also the future of our own journey of discovery. And so, as we close this chapter on quasars, let's carry that sense of wonder with us. Let's remember that the universe is full of mysteries waiting to be uncovered, and that each discovery brings us one step closer to understanding the grand story of existence. The journey is far from over, and quasars will continue to light the way, inspiring generations to come to look up at the stars and dream. As we bring our journey through the cosmos to a close, let's take a moment to reflect on the incredible story of quasars and their profound impact on the early universe. These luminous giants, powered by supermassive black holes, were not just cosmic anomalies. They were the architects of the universe as we know it, from igniting the first light that ended the cosmic dark ages to shaping the formation of galaxies and the vast cosmic web. Quasars played a pivotal role in the evolution of everything around us. Quasars remind us of the universe's boundless energy and creativity. They challenge our understanding of physics, push the limits of what we thought possible, and inspire us to keep exploring the mysteries of existence. Through their light, we've been able to peer back in time, uncovering clues about the universe's infancy and the forces that shaped it. They are not just relics of the past, but beacons that continue to guide us toward new discoveries. But beyond their scientific significance, quasars also remind us of something deeply human, our innate curiosity, and our desire to understand the world beyond our own. They invite us to look up at the night sky and wonder, to dream of what lies beyond the horizon of our knowledge. In their light, we find not only answers, but also new questions, new mysteries waiting to be unraveled. So, as we conclude this exploration of quasars, let's carry that sense of wonder with us. Let's remember that the universe is a place of infinite possibilities, full of beauty and mystery. Whether you're an astronomer, a dreamer, or simply someone who loves to gaze at the stars, quasars remind us that the cosmos is a story still being written, and we are all part of it. As you drift off tonight, let the light of quasars guide your dreams. Imagine yourself floating among the stars, surrounded by the brilliance of these cosmic wonders. Let their story inspire you to dream bigger, to explore further, and to embrace the endless possibilities of the universe. Thank you for joining us on this journey through the cosmos. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell so you never miss an adventure among the stars. Until next time, keep dreaming, keep exploring, and keep looking up. The universe is waiting for you. you.